Welcome to yet another video on cyclic geometry series. Now in this lesson we are going to explore another property whereby we'll be looking at the relationship between the chord of a cycle together with a line drawn from the center of the same cycle. Now let's just draw a cycle like that, and then in this cycle let's draw a chord. What's the midpoint of this chord? Now let's check it. Now the midpoint of this chord is here. That's point B, which is the midpoint of that chord. Just to prove that that is actually the midpoint, let's measure its distance. Now we have the distance of both BD and DC. And then from there, let's draw a line from the center to the midpoint of chord BC. Just remember, just a reminder, a chord is a line whose endpoints are on the circumference of a cycle. Now, what's happening here? Let's check the angle. Let's check the angle ADB. It's 90 degrees. So this is our property. So let's try playing around with this and check the angle. 90 degrees, 90 degrees, 90 degrees for as long as this is the midpoint, they will be 90 degrees there. Now let's try to state this property then. Let's try to state this property. The property is the line from the center of a cycle to the midpoint of a chord is perpendicular to the chord. And this works on any chord in the cycle except for the diameter, because the diameter is already at the center, so there can't be a line from the center to the center. It won't make sense. Like, so the line from the center to the midpoint of a chord is perpendicular to the chord. Line from center the line from the center of a cycle to the midpoint of a chord is perpendicular to the chord. That's our first property. This is our first property. Now the second property, which is going to be some kind of a corollary, or rather a property derived directly from the one above. Let's go straight to GeoGebra. We are exploring here. And this channel, we don't assume stuff, we present it direct with accurate measurement from the help of GeoGebra. Now, let's go straight to GeoGebra. And then in GeoGebra, we are going to draw two chords with the same length. Now here are the two chords in the same cycle and they are equal. Let's confirm. Let's just measure their distance. That's 6. This one is 6, so they are both 6 units. Now we have two chords in the same cycle with 6 units. Now we want to find their distance from the center. In our case, the length of the radius of this circle is 5 units. We can measure that. This is 5 units. Check that, that's 5. So if the radius in this circle is 5 units, what will be the distance of this chord from the center? What will be the distance of this chord from the center? So let's check. Well, those are perpendicular lines. We already have established that if they are perpendicular lines, they are going to bisect our chords. So this one is the midpoint of this chord, and this one is the point of the chord. Now, you want to find the distance. What's this distance? 4 units. 4 units. Wait, what's happening? Check again. From the center to chord BT, 4 units. From the center to chord CE, 4 units. Now, these two chords are equal. Now, this is a property. What does it say? 2 or more chords. 2 or more equal chords in the same circle are equidistant from the circle. From the center. 2 equal chords in the same circle are always equidistant from the center. So now we have our 2 properties here. The first one is saying the line from the center of a circle to the midpoint of the chord is perpendicular to the chord. Or you can rephrase the first one to say the line from the center of a chord. The line from the center of a chord the line from the center of a circle to the midpoint of a chord is perpendicular. We can rephrase it to say if a line is drawn from the center perpendicular to a chord, it bisects the chord. A line drawn perpendicular to a chord from the center bisects a chord. And then from that theorem, we have also established that 2 or more equal chords in the same circle are equidistant from the center. Now let's check examples on this. Our example 1, you are given that AC is equals to DC equals to 6 units. AC equals to DE and their body equals to 6 units. AC 6, DE it's 6, and then OB is for OB. It's this one, that's 4 units. That's 4 centimeters. And then we are noticing something here already. AC is this one. AC is a chord. DE, it's this one. And DE is also a chord and they are both equals to 6 centimeters. Now we have established from our second property that if two chords are equal and they are in the same circle, they are going to be equidistant from the center. So if OB is the distance of chord AC from the center, then also OM is also that distance, so they must be the same. So OM is actually 4 because these two chords are equal and they are in the same circle, so they must be equidistant from the center. Now check something else. AC is equals to 6. AC is equals to 6. We are seeing 90 degrees here. What does this 90 degrees tells us? It tells us that this is the midpoint, a line drawn from the center and being perpendicular to a chord actually bisects the chord. So this is equals to that. So we know that we need to get 6 for the whole of AC. So this one, half of 6 is 3. Half of 6 is, so that if you say 3 plus 3, you are getting the 6, which is the full length of AC. Same story with DE. So for DE, this guy is equals to that, because the line from the center perpendicular to a chord bisects the chord. So these two must be equal. So this one is 3 and this one is 3 units or centimeters. Now we've actually entered all the data we were given. Now let's go straight to the questions. Calculate the length of OA. How do you find OA? OA is actually hypotenuse given right angle triangle. So we are going to use the Pythagorean theorem. Let's call this one X. Let's call that one X. So what does the Pythagorean theorem say? It says that the hypotenuse squared is equals to the sum of the square of the other two sides, 3 plus 4 squared. Then your X squared is equals to 9 plus 16, and then your X squared is equals to 25. Then taking the square root on both sides, you are getting that your X is equals to plus minus 5. But since we are talking about distance, it's only the positive, so there's 5 centimeters. Now next question, write down the length of DM with reason. DM is equals to 3. Now let's see, DM is equals to half of DE. The reason for this is that line from center drawn perpendicular to chord actually bisects the chord. So your DM is equals to the half of 6, which is equals to 3 cm. Calculate BD. We first need to find this one, OD. But OA is equals to OD equals to OC. They are all already. The radius from the same circle will always have the same length. So if OA it's 5, this one is also 5. So the distance BD is equals to 5 plus 4, which is 9 units. So BD is equals to 5 plus 4, which is equals to 9 centimeters. Next, we are going to example 2. In the diagram, O is the center of a circle. PR is 12 and OQ is 8. OQ, O to Q, this is 8. P to R is 12. Now, let's check our theorem. We have a perpendicular here with a 90 degrees here. That is telling us that this is Q is the midpoint, which means this is equals to that. So if the whole of PR is 12, this should be 6. And this one, it should be 6, so that their sum will give us the 12. Next, what are we required to do? Calculate PQ. PQ. And then we know PQ is equals to half of PR. The reason Q is the midpoint of PR, since PR is perpendicular to the chord. Since PR, the chord is perpendicular to the line from the center, OQ. So your PQ is actually equals to half of 12, which gives us 6 centimeters. Next question, OP. It's this one here. Another hypotenuse squared. And we write this one here. The hypotenuse squared is equals to the sum of the square of the other two sides, 6 plus 8 squared. Then maybe let me use the OP here. So the OP is equals to 36 squared. 6 squared is 36 plus 8 squared is 64. So the OP squared is giving me the 100. Square root of 100 is 10. This is 10 cm. SR, calculate SR. How do we find SR? Now we found that this is 10. And this one is also the radius, so it's also 10. We need to find that one. So it's going to be 10 plus 8, which is SQ. So it's SQ. Let's first find the hypotenuse. The hypotenuse is the longest side, or the side opposite 90 degrees. So opposite 90 degrees, we have SR squared. This is equals to SQ squared plus QR squared. So your SR squared, this is unknown, is actually equals to SQ. It's 18. 10 plus 8. QR 6. Now let's take this one down here. So SR is equals to 18 squared plus 6 squared 18 squared plus 6 squared is giving me 360. Then taking the square root on both sides, getting that the answer is 18.97366596101. Now correct to 3 significant figures. It's going to give me a 19.0 centimeters. Next example, a chord is 4 centimeters from the center. Now let's try to put this one in a diagram so that we can have a clear picture of what's happening. Now a chord, we have the center there. That's our center. Now the chord, and then the chord from the center we have something like this. It's 4 centimeters. If the radius, now you are told the radius, this one, if the radius of the circle is 6, if this is 6, calculate the length of the chord. So we are going to first find this side, and then we are going to double it because this is the midpoint. Now the hypotenuse in this case is 6. Let me call this one x. The hypotenuse is 6, so 6 squared is equals to the sum of the other two sides, 4 plus x. Now 6 squared is 36 is equals to 4 squared is 16. This is equals to x, plus x squared. Now from there, let's subtract 16 from both sides. Then this side, the 16s are gone. Then you are left with 36 minus 16 is giving me 20 is equals to x squared. Now let's calculate the square root of 20. Square root of 20 is 2 root 5, which is 4. So your x is equals to 4.472135,955. And then correct to 3 significant figures. This is 4.47. centimeters. But then we don't want x, we want double of that. So your 2 x is equals to 8.944,27191. Then correct to the 3 significant figures. Then the length of the chord is equals to 8.94 centimeters. I'd leave this question for your practice. You are told that 2 parallel and equal chords are on either sides of a circle. Each chord is 10 centimeters long. The radius of the circle is 7 cm. Calculate how far apart are these chords. Now, just practice on this one and feel free to drop your solutions on the comment section. Peace out. Thank you for staying tuned.